harnessing gravity using light. What I've done, I experimented with light, and then I realized light can't control gravity. So can we make a generator using light? If it makes more electricity than we need, we have something there. So this is the purpose of my presentation. The summary, first I will see independent confirmation of what I've discovered, a description of some of the things I discovered when I did the experiments, a kind of common factor that was common for everything that I found. And with this common factor, can I explain what I found? And then other instance in space, even if I'm not an astronomer, and then how to harness gravity. Okay? First, two independent scientists found the same, well, similar results to mine. One is Changping Liao, when he was working at MIT. He published in 2014. And the other one is sitting right here, Libor Newman. He found his experiment was so, no, the result was so similar. I gave the graph of your experiment to my cousin. He thought it was my graph. No, I said, this is from Libor. So if three persons find the same thing, usually, is it true? Okay, thank you. Okay. This one, I didn't find it. I was born, but I was too young. So this guy, he found that it is possible to change light into an electron and a positron. So light can become electron-positron. That is important. Light can become a complex system, as we see here, named positron-electron. The next one, this is an experiment I've done. A flat laser beam will affect gravitational force on a mobile object. I had a 500-gram mass on each end. Do I have to point? I don't think so. You see it. And then the big mass sitting on the table, so the torsion balance could move. It was hanging from 3 fine copper wire. Instead of taking only one wire, because then you have what we call a torsion constant, 3 wires is better, because it's like a ribbon then, and when the balance turns, it goes up a little bit. So it's like gravity pulling the pendulum back. And we see here the masses, the fixed 909 gram mass, because it was in pounds. That's why you have that. It was placed near. And the small laser is sending a light on the mirror, reflecting on the ruler. So I was checking on the ruler where the point was moving, noting that, so it takes time. The 500 mass, according to theory, should be attracted by the big mass. Everybody knows that, attraction, gravitational attraction. And because Poklinov had this big wheel turning, and he found out that gravity was not deflected, but less. So I thought maybe light could deflect gravity. So if I can send a light beam between those two, then the gravity will be less. What will happen to the small mass? It will move away. Okay, this is the theory according to all what we have in physics books. And this is the arrow saying that it should move away. Okay, at first, the pendulum was moving slowly, as you see in the graph. And where the arrow is horizontal, it was almost stable near the big mass. It's not touching because I want to pass that laser beam. It's a flat laser beam at 15 degrees about. And the small mass was stable, so I send the laser beam in between. And what will happen? Well, after 160 minutes, when the laser beam You see, instead of going away, it was getting closer. So I made an error for sure. It's supposed to move away. So I shut the light, and look what happened. It moves back. So I did that for 9 months to find my error, because I knew that was not supposed. You see that it went back when the light was shut off. Okay, is it static electricity? I even put wires everywhere, grounded, same thing. Is it molecules of air that I ionize? Well, a red beam cannot ionize air. Okay, so is it Coriolis effect? Is it temperature changes? Is it? I tried so many things. It was always attractive, not supposed to. So, the only factor that was present is what? The light. So probably the light is doing something, attracting. Light is not supposed to attract. It's supposed to shine, okay? But that was what happened to me. So about 1,000 hours, I stopped, and really what I've done, it was a week, the student was gone, so I sat inside the fireplace and thinking, it's not possible, but it's there. It's not possible, it's there. And then, bingo. Well, I don't know if it's bingo. And Dr. Rubin, this is my friend Dad's there. He was teaching physics at Laurentian, and he said, this is against everything, and it's not possible, we cannot explain it. Okay, I couldn't explain it neither. And then, eureka, aha, maybe there's a force pushing there, and a force pushing there, and the light is blocking part of that one, so this one is bigger. Maybe. Hey, maybe it's working. Then I look on internet, and you know, a guy found that before me, Lesage and Fazio, in Newton's time. He talked to Newton about that, and Newton said, well, I don't know. But then I had a confirmation of something that was discovered, no, not discovered. They thought about it years ago. So how can I measure if that's true? Well, I just have to remove the big mass and to see if it's light that is moving the object. So I removed the big mass, and look what happened. When the light is on, the mass was moving towards the light. When the mass was off, the light was off. No, sorry. When the light was on one side, it goes that way. Push the light on the other side, it goes the other way. So yes, the small mass is attracted to light. Does it make sense? But that was a fact. Okay, I tried to understand why. I wasn't sure. Gravity coming from all directions seems to push the test mass. So we have to find if that's true. So the first publication in 2011, I wrote that it seems that gravity can be deflected by light. I didn't want to publish, by the way. I'm a teacher. I'm not a researcher. But a friend of mine pushed me, and I published. And the third time that I sent the paper, I said to my wife, if they don't accept it, well, the heck with it. And then the editor said, we publish. Okay, so they published the effect, and maybe that's why I'm here now. Okay. It was not possible to measure the relation. I tried to measure, but with a torsion pendulum, it's not easy. I tried many ways, so maybe I have to find another method. So I had to build another setup. At the Collège Boréal, when I was teaching, they accepted to, they had a big machine there, and they have a research department, so that helped me. So I built that box. It's about 1 meter long, about that thick, with big lamps, fluorescent lamp. They gave 63,000 lumen. Don't look at the light. It's very, very bright. I just took it in the picture, not the picture, drawing, so you can see inside. And I thought if it goes back and forth, every time it will cut gravity and I have a bigger effect. It was not true, I didn't know at that time. So if I put the mass under, and I put the light on. What should happen? If the mass is under, the light is over. Okay, let's see. The 200 mass lost 0.036% of its weight. And on the balance there, I could see that it was an old analytical balance from under the college, and the wheel starts turning backward. So that was fun. Well, it was fun for me. Okay, when the laser was on, you see the mass was constant. Oh, I put that in newtons now, okay, multiplied by 9.8, okay? And the mass was constant, the laser was on, start to go down. And then I shut the light, and the weight comes back. So it was the first time on planet Earth that we were able to lose weight. So anybody is interested now? Just put light under you, okay? And then you lose weight. But as soon as the light is off, you gain your weight. It's not very interesting. And then when the mass was over, now you gain weight. That was the first time we have an increase of weight without a change of mass. It's true. First time on planet Earth. Wow, that's something. The 200 gram mass, it gained 0.015% when it was placed over the box. And this is important because it's my grandchild. She was making a science project. So she tried with 1 lamp, 2 lamps, 3 lamps, up to 9, all the lamps, 9 lamps, yes, okay. And she found out that the percentage weight loss is directly proportional to the energy of the lamps. It was a straight line. So that's interesting also. And I think Libor, you thought out something similar. Have you tried that?
Okay.
Oh, okay.
I
Okay.
tried it a little bit different way.
No, different, okay. So I decided to build, this is another fact. I tried so many things. So I decided to pass opposite light of ray. I had another laser there with a Fresnel lens and mirrors, parallel mirrors. So my thought was, if every time light pass over and I diminish gravity, I'll put more and maybe it will float. Oh, that would be nice, huh? So I tried that. Well, this is my setup there. And you see the mirrors on each side, and the blue light there, and the laser. Oh, these facts that you will see now, they were not published yet. Maybe it will be published, I don't know. I'm retired now. Okay, so what happened here is that the light reflected between the two parallel mirrors tend to coalesce into one ray. It's not supposed to. When the light was bouncing, I was sure that it will come out there, but it stopped and become just a big band of light. The maximum I was able to get by trying to adjust the mirror was about 70 reflection. Well, according to the laws of light, the incident ray should be the same as the reflected ray, the angle. It's not when you have more than one. Why? Okay, well, maybe you can make a project on that. So that's not published yet. The next fact, because light can affect gravity, my question was, can affect also electric field? Well, we'll try it. One of my students built a little sensor because he made an error in his project, and using a CMOS chip, and he knows about that, he was teaching electronics, and he built a sensor so good that about from here to empty, I don't have hair, but I would go like that, and the detector will sense the change at about 3 meters, so that was sensitive. So the concept of force field was invented because, this is a digression, because we didn't know exactly what's happening between the sensor and the object that is charged without contact. A field is supposed to be present everywhere instantly. An obstacle is not supposed to block the field because it's everywhere. So many think that the force field is not a physical reality, but a theory to calculate the effect. So this is what I've done. This is my sensor, and I have a plastic a ruler that I rub, and when the galvanometer needle moves, that means it feels an electric field somewhere. And if I move a paper in between, it stopped. A small paper will block the field. Even a wooden pencil, you just put it in between, and the sensor doesn't feel it anymore. So it's not supposed to be like that. Maybe you know why. At that time, I didn't know why. So I have a small antenna. This was in a tin can made of iron. It's called a shield. What do you call that again?
The Faraday cage.
A Faraday cage, that's right. To make sure only the antenna would receive the field. The detector, and when a small neutral paper moves between them, the needle returns to zero. Okay?
The charged object is the blue.
Say that again?
The charged object is the blue.
Yeah, this is my ruler.
Okay.
Plastic ruler rubbed with plastic something. Okay. Okay. If light can block gravity, can light also affect the electric field? So I know that an object can block the electric field, but can light block it also? So I bought a big projector made in China, supposed to give 1 million lumen, supposed to, big one. But the problem is the coolant that they put inside was not good enough, and it went on, off instead, so you cannot use it in your shop. But it's good, it's about 1 hertz light, flashing, a very strong light. So before activating the 9,000 lumen projector, the needle there moves when an object is close. It was moving like that, and because it was humid, the object will discharge, and the needle comes back slowly to zero. Okay. So the needle at a constant motion, that was important in humid air. Okay, so now we'll use the projector, and we'll use the plastic ruler, the sensor, and this will go on and off at about 1 hertz. So when there's only light, the needle is at zero, meaning the light does not affect the sensor. So I put the ruler, and the object is brought closer, and the needle moves, but it comes back by increments at the same frequency as the light. It's not supposed to. The light is not supposed to block static electricity field, but it does. Why? I didn't know exactly why. Okay. Now the next question is, well, why not? If it blocks gravity, blocks electric field, can it block magnetic field? So I built a little apparatus last summer. It was fun. Okay, what you see in blue there are magnets opposite. So the north pole is blue here. And the laser there, the beam reflected from the mirror, will cut gravity, horizontal gravity, by the way, not vertical gravity. And what will happen there? That mass will move towards the light. And there's another mass at the other end. Okay? So at first, I do it just like that to see how much gravity was blocked. Because the magnets do not act as magnets, now they're free. They act as weight. Okay? Brass there. Light blocks gravity. I measure how much. Okay? And then I put 2 magnets on each side. North pole against north pole. So the middle one there cannot move that way, cannot move that way, because there's the north pole on each side. So it's stable. Then I send the light in between. Do you think there will be a difference? You say, yes, I know. Okay, yes, there was. Okay, 2 external magnets there. And, okay, this is interesting. You see, the whole pendulum was swinging slowly, but when the light was activated, it stopped going that way and became almost horizontal. And I look at the percentage compared to just gravity, and it's about 10% because of the magnet. But remember, the magnets were far. They were about that distance. So if I didn't try it closer, I had my answer. Yes, light can block magnetic field, electric field, gravitational field. But how? How does it do it? So that, yeah, but something happened. So what I wanted to know why, what was common in all these? Well, first, light can become electron, positron. Light can block gravity, can block electricity, can block magnetic field. And the next part, okay, the possible cause of these 7 facts that I've seen. An object with surface electron seems to emit something in straight line, because if I put a pencil in between, it was in straight line. It seems to emit something. These emissions are not electrons, because you can have the electric field very far. The density of the emission increase in front of the moving object, because if it's moving in front, there's more, the density of the emissions in front is bigger. And if the object is moving back and forth, that will give kind of picture like that. That's cute, huh? Okay, so you have different densities going outward. That's in 2D, but really that's in 3D. But it gives an idea that a charged object seems to be emitting something. What? And the voltage intensity, if we measure the voltage, it gives a sine curve like that. And this is similar to, well, normal visible light. The effect of a vibrating charge on a sensor. If I have, instead of a charge just there, I go like that with a charge, the needle will go like that, because the electric field increase, decrease, increase, decrease. When the charged object vibrates at 1 megahertz, the sensor, well, my needle cannot vibrate at 1 megahertz, but if it's an oscilloscope, I would see the voltage go at 1 megahertz. Now, I asked Superman to come to help me. Everybody, you know Superman, huh? He's fast. So I give him a comb, not in his hair, because it's teal, okay? So he had the charged object, and he goes very fast. At 300 terahertz, it was visible light. That was fun, huh? No, it's structural, okay? But that would be nice, okay? If you can vibrate something at that frequency, the electric field that you would see would be visible light. Interesting, huh? Okay. These 7 strange facts could be explained logically with the concept of entities emitted by atoms interacting with the atom system. You were talking about entities also. What are they? Well, some people call it quanta. I'll use the word entities. I don't know what they are. The intensity of these emissions decreases with the square of the distance, just like gravity. Incoming entities in the system are about the same amount as those emitted by the system. So if an electron receives entities, it will grow big, big, big. No. It emits probably the same amount it receives when it stays an electron or a proton or a neutron. Electric field is probably this. Entities emitted without frequency in a radial pattern by objects with a surface electron. Maybe that's not true, but maybe that's true. So keep an open mind, okay? Gravity would be entities emitted in our direction without frequency. Okay, and light emitted also in our direction, but with frequency. Maybe that's true. But I can explain all the facts that I've seen using that. Those interactions could cause gravitational force, electric force, light, and they will be the ultimate smallest entities. They cannot have spin, electric charge, or mass or energy, because spin, charge, mass, energy would be the properties associated to systems, not to the entity itself. Entities interacting with a system become part of the system. So if you have an electron, entities coming more dense on this side, what will happen? It will probably go in the electron, and the electron will just move away, like if it was pushed by these entities. Interaction are neither pushing or attracting. It's not a pushing force, not an attracting force, but cause an internal reorganization of the system. And the system itself is reorganized further, as if it was pushed. Well, maybe it's not true, but it makes sense. These ultimate entities can logically have only 4 properties. They're not made of something else, so they don't have any size. They need to have a very small interaction zone, otherwise they cannot interact. And they always move at the speed of light. And because they're not made of something else, they have to be maintained in existence continuously. This is a bit like Feynman is talking about virtual particle popping out of existence. Maybe it's true. Using these properties, it was possible to explain the 7 facts that I found. First, if you look at this, it makes sense. If light is made of a lot of these entities and it passes through a very thin lead sheet, it reorganizes itself as a proton and a positron, and the proton and positron become light again. So maybe, like a snowman, by the way, in Canada is made with snow. Okay, an electron might be, and I think as Arthur said, everything is made from light. Oh, I call that entities. It is possible that these entities are the same. When a system is disrupted, like a positron meeting an electron, it becomes a gamma ray. And now, if we look at my experiment, a light beam under an object, you have gravity on each side. The one under is a bit diverted by the light. So what happened is the weight increases. No, if the light is over, it decreases. Sorry, we have to think about how the vector is there. Okay. And an horizontal light ray blocks some entities coming from above. If the light is over, and then the 9.8 Newton will become, well, 9.6, okay? But I put 8 for fun. Okay. There is less interaction to move the atoms downward, so the weight decreases. Now, a light ray going in opposite direction. This is what I found funny, because when I had those beams going in there between the mirrors there, the effect was 100 times less than one beam. So I didn't know why I talked about that to my little, my grandchild was in physics at Laurentian University, and maybe it's diverting. So maybe when a light ray goes like that, maybe it pushes something that way, and the one coming back pushes it back. So the effect is almost zero. And when I built the first big box with those light rays bouncing, I had an effect. But I should have tried without the big mirrors, but it was too late, okay? Probably the effect would have been a lot bigger. So this concept explains that. Now, entities coming from space can also explain why the light at one point is not bouncing anymore at an angle. It's not reflected according to the law. Maybe each ray of light is blocking some of those entities coming, and what would happen, this would be enough to just prevent the light going up. Even I moved the mirrors, I was not able to have it out. An object with surplus electron will emit entities in a radial pattern, so we know that. A neutral object can interact with these and deviate the emission, so that's why a pencil will block static electric field. A sensitive probe will detect the change of the intensity. And also, an intense light can block static electricity also, if the entity is emitted by the electron, and in the light source, it is possible these interact with the entity of the field, entities of the light, entities of the field. And that would be enough to decrease the intensity of the static field. Other instances in space. If it's true in our world, and if it's true in astronomical world, maybe it's true. So I was looking at Mercury, and between Mercury and the Sun, there's no planet there. But according to Newton's formula, you could have a planet there, but there's none. So maybe the resilience of space system and of atom system, it's called the anti-effect, because of my friend Anti who suggested that we were talking together. And anti means also opposite. Okay, so his name is opposite to his wife. No, that's okay. Okay, so maybe if you have the sun and you have entities sent by the sun, no, we ignore the entities sent by the sun first. Look at all the entities in space. Some of them will be blocked by the sun and they won't go through. So around the sun, you'll have a depletion right near the sun. Okay, the sun, those passing through the sun, they will have, and I think I have arrows to show that. Okay, after it passes through, the density increases. So the one coming here is less here, but here you have more because remember that you have vectors coming from each side. So you have a zone, a depletion zone from space around the sun. But remember, the sun itself, the sun itself is emitting that too. So it decreases with the square of the distance. Now, if you add those two, you will get a kind of gravitational bubble around the sun, where there will be less here. If you add what's going from the sun, what's blocked by the sun, and also what's coming from space, and also you have the centrifugal force when the planet is turning. Add all these, and you'll have the red line there is the total. So there is an anti-bubble around the sun where the density is lower. The purple line is the constant centrifugal. Orange line is the entities coming from space and it's pushing toward the sun. All the rest is pushing away, and this one is pushing toward the sun. The red line is the total. And if you look at the planet now, they are all about 1 exponent 10, if you look at our planet, meters from the sun. And if you look at the graph, this is where the low spot is. Interesting. So the planet would probably reside in the gravity well. Okay, so the sun is emitting, so there's more density here. The space is emitting, but there's a well, and the planet, depending on its speed and its mass, it will find a spot where both forces are equal, and it will continue that way. Maybe that explains the resilience of the solar system. And that's where Antti said, maybe it explains the atom also. Maybe there's a spot around the atom where what's coming from space, what's coming from the nucleus is less. So the electrons will circulate there when they are systems, not waves. Okay, what are the entities? Nobody knows what is light right now. Maybe you know. We call them entities. Entity means something that exists. And the four properties I put there, it may be light, maybe gravity is light, maybe we're all those entities here, organized as a system. Well, some people call them quanta, I don't know.
So visible light, the quantum of visibility.
Well, quantum means something else. Graviton means something else. Graviton has properties. These, they don't have, they exist, they move, and they interact, period. Okay, I don't know what they are. Maybe somebody will know here. I don't know. Okay. One thing interesting. Look at, this is a picture from Eleanor Lutz. And she drew all the planets moving. And you see the anti-bubble there, where it's less. And the Mercury orbit, if it tries to get closer to the sun, entities on the sun will push it away. And same thing with the other orbit, Neptune orbit. And it's about at the end there. So this is interesting. Well, this is a kind of sideline there. It's not about my experiment. And now, I have a question for you. It's called unidirectional gravity. On Earth, a mug of beer, 1 liter, has a weight about 10 newtons. Is that true? About 10, round off. So that's 1 exponent, 1. Okay. Now, if we pass a ray of light under your beer, you ready? We pass the light under, strong enough to cut all the gravity coming from under. What will be the exponent there? Okay, yeah. We got all the gravity coming from under.
2.
How much? 2?
0.
11?
Less than.
Less than 1. Okay, another answer?
What was the question?
How much is your answer?
What was the question?
You cut all the gravity coming from under because you have a very strong light going under the bug.
I would say 0.
Okay, he says 0. Okay. So what we'll do...
10 to 0.
Okay, this is what we'll do. We'll go on a star that is called a neutron star. Okay, you know what a neutron star is? You know how much is the weight of your beer? That much. A million Newton. Okay, so probably the neutron star is cutting the gravity coming from under. Now we go back to the question, if I cut all the gravity from under on Earth, unidirectional gravity, you still say 0? Probably not. Okay, so if we go back to my question first, a better guess. What will be the exponent? Auntie?
Well, we talked about it earlier. It'll be very big.
Probably 12 or more. Probably unidirectional gravity is probably the strongest force on Earth. And people say gravity is not strong. Why? Because it's always opposite. My head is pushed that way and that way. 0. I'm happy about that. But that way and that way, okay, have friction. That is why it is possible to build a generator using horizontal gravity. You see why I want to come to this. Okay, harnessing gravity. What would be the next step to harness gravity? So look at all the discoveries I've made, and admitting gravity is caused by space entity interacting with matter. Then we need a powerful light. Make sense? Because I tried, the strongest I tried was 3 watt in my laser. It's not very strong. The light beam cannot go back and forth. I tried with mirrors to have the light beam going around. No good. But this might work. A coil made of fiber optic. I tried with my 3 watt laser, and I had this, you call it something that measures gravity in my phone. I don't remember the name of that. And I put the light on, hey, what? Nothing. You know what happened? My coil was made of plastic fiber. It just melted the plastic. So we need a glass fiber. But I don't have the expertise for that. I don't want a pension, so anyway. Okay, light in a fiber optic coil always move in the same direction. So that means every turn of the coil will push light, gravity in one direction. And what will happen? If you have enough, you can make a wheel turn and produce electricity. If your laser push light inside, the gravity will be moved, diverted. That means the gravity coming horizontally that way would be bigger than that way. The wheel turn, connect it to a generator, take the electricity from the generator, feed it to your laser. I call it a flywheel if you want. Any wheel connected to a generator will turn. And that you can connect to a generator. But, okay, less gravity from the one side will make the wheel turn, we know that. It will reduce the torque, activate the generator. And this is two models that we can make. This one here, the nice thing about that is the gravity is pushing that way. No, less gravity here, so more here. Less gravity here, more here. So you're using those coils all around, or you can take a big cylinder around and do the same thing. So I mean, these are possible things. But you need somebody with expertise with lasers. I don't have. And he has money or a lab. I'm retired and I had fun. Okay. And the generator using gravity, this is an example. And the nice thing about that is free energy if you can make more electricity than you use for the laser. And this effect will allow us to have clean energy and for years to come. All based on proven experimental fact, not on theories. Okay, so this is my presentation, but if you have comments, I have an email on the site there. You can give it to me, but if you have questions, because we have to go and eat, I remember that, okay? Okay, questions?
Yeah, any more questions?
Okay. Okay, the mic there, he thought he was alone when he found that light was blocking gravity. So there's something new. It's called, en anglais, a kind of worm. You know what I mean? A kind of worm. And he knows because we have to look at all our theories because Dr. Rubin said there's nothing in physics to explain that. And if you look at all the theories, even Maxwell equation could not forecast that. So this is something new, and I did that for fun. I didn't want to publish. I did that, and one guy said, why don't you publish? I said, let them find out. I was working on that for 50 years. Okay, is that enough? Because I thought for 52 years, science, I like that. So when I found it, hey, I got it. Tell people, why? Okay, find it yourself. But so I published, and here it is.
All right, one last question, and then we'll wrap it
Yes.
up.
Okay, well, thank you again.
Okay, thanks.
The mic is on? Good, okay. Well, first I want to thank Jan for inviting me and his team because they were very patient, okay. Harnessing gravity using light. What I've done, I experimented with light and then I realized light can't control gravity. So can we make a generator using light? If it makes more electricity than we need, we have something there. So this is the purpose of my presentation.